Okay, thank you. It's my great honor to share my research here. The topic is about the collaborative optimization for large B2C commerce logistics, mainly to solve the issue how to fulfill split orders. Uh, as we all know, the online retailing is experiencing explosive growth in recent years all over the world. The online sales already account for around 1/4 of the total retail market, and the share is still growing fast. So my research focuses on the behind the process that everyone have the experience shopping online, but what happens between after you place order and you receive the package? It's called the order fulfillment. That if a customer places an order in the online stores, then the orders are processed by the order processing center, and then the order is assigned to one or multiple warehouses or fulfillment centers to fulfill. Then for each warehouses, the orders are through the order picking, the order sorting, order packing. This process, then the orders are into the shipments or parcels. Then the parcels are delivered through the shipping network, through the sorting centers or shipping or delivery stations. Mainly use long haul delivery or the last mile delivery then to the customer. So my research is focused on the order fulfillment process, mainly do several studies among them before order arrives the storage or location, and after order arrive or do the order location, order picking, consolidation, shipping. There are among a lot of decisions to make. Today, my talk is about the consolidation here. It's based on several recent experience. First is just this week I buy something through the online market JD.com. That we have take a group picture, and I don't have the tie, so I buy a tie through JD.com, but it does not fit satisfy the conditions of free shipping. So I buy another product, tissues. However, this one order are split into two sub orders and delivered 2 times. Last day I received one package, and today I received another package. Also, when 2018 I visited the University of Arizona, America, in the Tucson city, I bought some groceries through the Walmart.com. Also, I found the similar phenomena that the shipments orders are split and the shipments are delivered by 4 times. And this order splitting issue can cause several serious challenges. First, for one order, you deliver several times, so they cause the high shipping costs for the online retailers. And the second one is multiple packages for your order cause environmental issues. Also, one order, multiple delivery cause customer unsatisfactory. This is because that one order contains multiple items, and the items are located in multiple warehouses. So they can have all the split issues. So how to save these all the split issues? Here is an example to show that if you place an order, it contains 10 SKUs. SKUs means as stock keeping units, it means items. And these 10 items are stored in 10 different warehouses. So they have to split into 10 sub-orders and fulfilled separately. And each shipment has a corresponding cost. So they cause high shipping costs, customer unsatisfactory, and the high pollution. These issues. We propose use a consolidation approach to solve the split order that after the order split, we can transship the orders, transship the items from the warehouses to a central consolidation center and pack it together. Then we can ship your orders in fewer packages on the shipments. Because that split order can cause multiple shipments per order, so they have the high shipping cost, high pollution, and low customer satisfaction. But if we do the consolidation, we can reduce the number of the packages per order, so we can reduce the shipment per order. So this issue can be solved. But when we use the consolidation, there are several problems. The first one is which split order to consolidate. Not every orders need to consolidate. The second problem is that where to consolidate. We have to choose the assembly center to consolidate each order. And the other is when to consolidate, because the assembly or the consolidation of the orders can only be started after all its audited items are arrived at the consolidation center. So today I'm going to talk this working paper, when to consolidate. It's because that today's online retailing are provided the fast and free fulfillment services, but they have the double portion of the cost and the time. Like Amazon provides the same-day deliveries, and JD and commerc in China provide similar services. They face the increased fulfillment cost and customer expectation for fast shipping. If the delivery cannot arrive on time, maybe customer will abandon the merchant. So how to provide the on-time order fulfillment at a lower cost? So for the split orders, we can treat the consolidation of the split order as assembled to order system, which is a typical system is manufacturing areas, because they have this feature that the assembly can only start after all items or an order in different warehouses around. But the difference is that the number of the final assembly products is exponential in the set or the catalog. In the current practice, the online retailer conducts a separation decision that they first make the assembly planning decision to select which assembly center to assign for each order. Then for the arrived item, they make the assembly operation decision, which means that we have to choose which assembly period for each order to consolidate. However, these separation decisions may cause a lower fulfillment cost in the first stage, but cause a higher fulfillment overtime or workload costs in the second stage. According to our investigation, 14% of the customer complaints for JD and commerc in China they are related to the fulfillment overtime issues. So there two decisions are closely related. So we are considering that we make the integration decisions. However, this have to make the assembly operation before we make the transshipment. This is because that the assembly operation time for orders are uncertain, so we have to make the integration assembly planning and the stochastic operation problem in the assembly operation stage, because we do not know the assembly operation time for each order. So we also have to make the decision that which order should be transshipped to work overtime if the assigned orders are over the capacity of the assembly period. We have some data we can show that the assembly operation time is uncertain. And before the formulation of the problems, we do some problem analysis for the two decisions, assembly plan decision and the assembly operation decisions. The assembly planning decision decides the transshipment cost, the assembly cost, and the shipping cost. And for the operation decision, we decide the workload cost and the overtime cost. For these two decisions, integrated, they decide the overtime cost. Overtime, it is a regular assembly overtime plus the actual assembly time plus the shipping time minus the due time. Also, because all order assembly time is certain, if we know the order assembly time is the operation stage, we have to check the condition whether the total assembly time is lower than the capacity. If it's lower, then all of the orders are regular orders. They do the regular assembly. If not, then we have to select some orders to transfer the workers to work overtime. We call it the transfer orders. For these two kinds of orders, they have the assembly time and the workload times are different. Also, the assembly time are different. Then we show the two-stage stochastic formulations. We mainly have two variables, x and y. X means that the order x is assembly in period P of the assembly center. Y means that this decision is successfully operated. So here is the formulation. In the first stage, we minimize some of the transshipment costs, the assembly costs, the shipping costs, and we have to satisfy all orders are assigned and the assembly starting time requirements. And for the second stage, we have to minimize the workload costs and the order overtime costs, and should satisfy the assembly period capacity, assembly operation time satisfied. And for the two-stage stochastic formulation, we transfer it, use the sample average approximation and transfer it to the deterministic problem. Before we propose our algorithm to solve the formulation, we first propose an optimal policy in a single assembly center. This policy is mainly to decide that if an order is over the capacity of one assembly period, then we have to make the decision whether to transfer the orders. It means the work overtime to finish this order, or we can postpone this order into future another period. So there is a trade-off. We can find the best conditions to make this trade-off. This theory can be used to reduce the solution space before we develop the decomposition approach. Then, because the two-stage formulation has issues of the number of scenarios, so we have proposed a new scenario decomposition approach. In this decomposition, we aggregate the scenarios into the subproblems. In a classical decomposition, that each subproblem are still decomposed according to the scenarios, but we can aggregate this scenario into this approach. The advantage is that we have a small number of the subproblems. Then the master problem can be easily to solve because each integration we have the added cards from the subproblem. Then for the approach, we have the master problem and the subproblem. For the master problem, we mainly decide the assembly planning decisions, and with this decision made, then we made the assembly operation subproblems decisions. To enhance the master problems, we added the lower bound of the subproblem to the master problem. Here is lower bound, and then to ensure that this algorithm can converge to the optimal solutions, we propose two optimal cards that can be added to the master problem. Here is the overall framework that we start with the optimal policy in a single assignment center that can remove the dominant solutions, and then we added the lower bound of the subproblem to the master problem. Then we can solve the master problem. If the master problem is feasible, then we solve multiple subproblems according to our scenario decomposition approach. Then if they are equal, then we can finish. If not equal, then we add the banded card to the master problem and do the iterations. Next, we show the computation results. We have some real data and some simulation data. And we first do the SAE analysis to ensure the number of the scenarios. And then we show the performance of a decomposition approach. First one is the decomposition approach is perform much better than the solver. Here we use the simplex. And then we can show that compared with the classical scenario decomposition method, or decomposition method is much better. And the behind the reason is that we have a lower running time percentage for the master problems because we have a lower number of added cards in each iteration. But the number of the iterations is a bit higher. Then we further see that this scenario decomposition can greatly perform much better when we increase with the number of scenarios. And we can see the scenarios increase from 100 to 500. The running time can only increase a little. Also, this performance can work for another implications of decomposition algorithms. The last, we demonstrate the value of the integration decision.
Could you go back one slide? Could you go back to the? Yeah. So what is this percentage? Is this runtime or?
Yeah, if they can get the results in 30, let me think, in 3,600 seconds, we have the best results. If not, we report the gap of the result.
Okay.
This slide is to show the value of the integration decisions compared to the separation decisions. So the integration decision can reduce the cost. This is done by reduce the overtime cost and the workload cost. But the integration increases the fulfillment cost. But overall, we can reduce the total cost. The behind reason is that we can transship the item to a warehouse maybe longer, but they have the fewer workload. Say the so the fulfillment time may be less, so the total cost is reduced. So in the conclusion, we for these new problems, we propose a two-stage stochastic integration model. I think it's new. Another one is that for this problem with scenario complexity, we propose a novel scenario decomposition. It's also novel to the stochastic programming literature. Here is my talk. Thank you, everyone.
Thank you very much for this very interesting presentation, Yuankai. Are there some questions? So I will stop the